Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. See the next topic, entropy. It is represented by S. The measure of randomness or disorderness of the particles of a system is called entropy. It's very simple definition. Randomness or disorderness, that means irregularity of the particles in the system, is called entropy. This entropy depends on the temperature and pressure of the state. Temperature changes, entropy will be changed. Pressure changes, then also entropy will be changed. This entropy is a state function and extensive property. Already we know that state function, the thermodynamic property which depends on initial and final state of the system and is independent of the path how that final state is reached, that is called state function. So depends on initial state and final state, its value is considered. So entropy is a state function and extensive property. It depends upon the quantity and size of the matter present in the system, that is extensive property. The entropy change delta S is related with Q and T for a reversible reaction as delta S equal to heat energy supplied in a reversible reaction Q or EV divided by capital T, that means temperature in Kelvin scale, or delta S equal to entropy of the products minus entropy of the reactants. Next, the total entropy change delta S total for the system and surroundings of a spontaneous process is given by delta S total equal to delta S system plus delta S surroundings. This sum should be greater than 0 for a spontaneous process. Remember students, for a spontaneous process delta S should be greater than 0. Okay. Here this is change in entropy of the system, change in entropy of the surroundings. If we add these two, then if it is greater than 0, then that corresponding process should be spontaneous. Next, when a system is in equilibrium, the entropy is maximum and the change in entropy is delta S equal to 0. Suppose a system is in equilibrium, then the entropy is maximum in that equilibrium condition and change in entropy delta S is 0. For a reversible process, delta S is 0. For cyclic process also, delta S 0. Students, remember all these points. These are required for multiple choice questions. When a system is in equilibrium or process is reversible or process is cyclic process, delta S change in entropy is 0. Next, both for reversible and irreversible expansion for an ideal gas under isothermal conditions. Isothermal condition means at constant temperature. If we consider reversible expansion of ideal gas or irreversible expansion of ideal gas, delta U equal to 0, change in internal energy equal to 0 for both the cases, reversible expansion and irreversible expansion. But delta S total, that means delta S system plus delta S surroundings is not 0 for irreversible process. If we consider change in entropy for reversible process, that is 0, but in case of irreversible process, delta S is not 0. Thus, delta S can discriminate between reversible and irreversible process. Suppose for a particular system, particular process, delta S is 0, then we can consider that is reversible. Delta S is not 0, then we can say that is irreversible process. Okay. Next, important formulae for reversible change of ideal gas. Reversible change for an ideal gas in different conditions. First one is isothermal process, reversible isothermal reversible process. Isothermal means temperature constant. So what are the variables? Volume and pressure. So delta S change in entropy equal to Q or EV divided by T, that equal to work done. WREV by T into nRT ln V2 by V1 divided by T. So T get cancelled. Then we can get delta S equal to nR into ln V2 by V1. Change this into log. Then we can get delta S equal to n into 2.303 R into log of V2 by V1. Initial volume V1, final volume V2, or universal gas constant n, number of moles of the ideal gas. In terms of pressure for isothermal process, pressure changes, then entropy change delta S equal to n into 2.303 or into log of P1 by P2. Next, isoboric process delta S equal to, isoboric means at constant pressure, change in entropy delta S equal to 2.303 into n into Cp into log of T2 by T1. In terms of volume, delta S equal to 2.303 into n into Cp into log of V2 by V1. In isoboric process, isoboric means at constant volume, reversible change for an ideal gas is delta S equal to 2.303 n into Cv into log of T2 by T1. In terms of pressure, formula is delta S equal to 2.303 into n into Cv into log of P2 by P1. Now say this, QREV is the heat supplied to a system at a temperature T under reversible condition. So all these formulae related to reversible change for an ideal gas in isothermal, isoboric, isochoric processes. Now see the related numericals to these formulae. For an ideal gas, Cp for monoatomic gas equal to Cpm, here M means monoatomic gas, Cpm equal to 5 by 2 into R. Calculate the change in entropy suffered by 3 moles of the gas on being heated from 300 Kelvin to 600 Kelvin at constant pressure and constant volume. At two conditions, we have to calculate change in entropy. First one is at constant pressure. The change of entropy as a result of variation in temperature at constant pressure is given by delta Sp, change in entropy at constant pressure, equal to n into 2.303 into Cp for monatomic gas into log of T2 by T1. Substitute T1, T2, number of moles 3. Here Cp value 5 by 2 into R means 8.314, T2 600, T1 300. Then we can get 43.22 joule per Kelvin. Next, the change in entropy at constant volume is delta Sv equal to 2.303 into n into Cv for monoatomic gas into log of T2 by T1. For monoatomic gas, what is the Cv value? 3 by 2 R. Substitute that one. So delta Sv equal to 2.303 into number of moles 3 into 3 by 2 into 8.314 into log of T2 600, T1 300. Then we can get delta Sv equal to 25.93 joule per Kelvin. Okay. See the next one. Calculate delta S for 3 moles of diatomic ideal gas. In the previous question, monoatomic gas, here diatomic gas, which is heated and compressed from 298 Kelvin and 101.135 kilopascal. Initial temperature pressure is given to final temperature 398 Kelvin and pressure 506.625 kilopascal. Given Cp value is 7 by 2 R. See this? The entropy change as a result of variation in both temperature and pressure. Students, understand carefully. Previous question, At constant temperature and at constant pressure, we calculated entropy change. Here, at the same time, two properties are varying. Those are temperature and pressure. Both these properties are varying. In that condition, delta S we want. So delta S equal to N into CPM into 2.303 log of T2 by T1 plus R into 2.303 log of P1 by P2. So Cp value for a diatomic gas 7 by 2 R. R means 8.314 into 2.303 into log of T2 398, T1 298 plus R into R means 8.314 into 2.303 log of initial pressure 101.325, final pressure 506.625. By doing calculation, we can get delta S minus 14.883 joule per Kelvin. Okay students, practice well.